Hey math enthusiast, I'm here to review some properties of tangent lines in circles. So just to review a little bit, a tangent line is like line AB over here on the right, touches my circle at one specific point. Now, it can only be tangent to the circle if and only if it is perpendicular to the radius or diameter. Doesn't matter which one. Alright, so as long as these two are going to form a right angle right here. Alright, so that's only a tangent and a radius or diameter. So for these first couple problems below, they tell me that BC is a radius of circle C. So this is a radius of my circle. It goes from the center to a point on the circle. I want to figure out whether or not AB is tangent to that circle. So I want to know, does this segment right here only touch my circle at one point? So if I continue drawing it, does it really only touch my circle at that one single point? Now, if AB is tangent, what has to be true is that this right here has to be a right angle. So what I'm looking at then, if it is a right triangle, where this leg is 3, this leg is 6, and this leg is 7. Now the question is that actually a right triangle? Now if it is, I'm going to know that this leg squared plus this leg squared is going to equal the hypotenuse squared. All right, but the question is it actually equal? So when I go through and square these, I end up with 9 and 36. On the other side, I have 49. Well, when I add these up, I get 45, which is not equal to 49. So in this case, the answer is no. AB is not tangent because this right here is not a right angle. So for the next one, it's the same question. They just want to know, is this segment up here tangent? So in other words, does this form a right angle? So this right here, is it a right triangle? We have 3, we have 4, and this third side is 5. Well, you might recognize these numbers, 3, 4, and 5, as one of my triples. But I'll plug them into the Pythagorean theorem anyway, just to show you that after I add them up, I do end up with 25 equal to 25, which does tell me that yes, this is a right triangle, which means that this is tangent to my circle. Now, the next problems have a similar setup. I still want to determine whether or not DE is tangent to my circle. But let's take a closer look at these problems. So once again, I'm just trying to figure out, is this a right angle here? So is this triangle a right triangle, essentially, is what I'm asking. So if I were to sketch this out, I know that this side is 3, my radius. This is 4 up here. But now what they're showing me is that only this piece is 2. So from here to here is 2. Now the thing is, the rest of it from here to here, well, that's just the radius of my circle, which I already know is 3. So this other piece is going to be 3. Well, that means that that whole entire side is going to be 5 together. All right, because it's going to be 2 and 3. Well, this is the same exact problem we had last time. I have the 3, 4, 5, so I know that if I plug it into the Pythagorean theorem, I'm going to get a squared plus b squared equal to c squared. So once again, the answer is yes. Now, this next problem has a similar setup. I'm trying to show that this is a right triangle. So if I sketch it off down here, I know that this side is 9 right here. I know this side up top is 15. And then once again, they give me this side that's 9. And then since the radius is 9, I know that this piece in here is also 9. So if I add those two up, that's going to give me 18. So once again, I just want to go through and check, does this work in the Pythagorean theorem? So a squared plus b squared, is it going to be equal to c squared? So I'm going to end up with 81, 225, Over here I have 324. So I'm going to have 306, which is not equal to 324. So the answer is no. It's not going to be a right angle here, so it's not tangent to my circle. Now, this next problem is very similar to the last couple that we did, but now they're asking, is B a point of tangency? So that's just another way of saying, is segment AB tangent to my circle? That would make B a point of tangency. So in other words, does my tangent here, this segment, and my radius, do they form a right angle? So once again, I'm dealing with a right triangle. Okay, I want to figure out, is it right? This side is R, my radius. This top side is 77. And as for the hypotenuse down here, it's going to be this piece, which is 49, and this piece, which is R. So that third side right here is going to be the sum of those two. So it's going to be the radius plus 49. So now I'm just going to take the side lengths from this right triangle, plug them into the Pythagorean theorem, and check to see, is it actually going to be a right triangle, because I'm not really sure at this point. So my first leg we'll say is R. My other leg is 77 squared. And then on the other side, the whole hypotenuse is going to be R plus 49 squared. So this is still going to be R squared. 5,929. Now remember, when you're squaring this, it's really going to be R plus 49 times R plus 49. So let's take a minute, we'll go through and FOIL this. So I'm going to end up with R squared, 49R, inner 49R, and the last 49 and 49, which is going to give me 2,401. So it looks like I can combine a couple terms here. We got 49, sorry, this is supposed to be 49R and 49R. So now I'm going to have R squared plus 98R plus 2,401. And then on the other side, I still have R squared, and I still have 5,929. Now, what's going to happen when I start moving stuff around is, as soon as I subtract R squared from this side, it looks like both of them are just going to disappear. Okay, so my R squareds are gone. So the next thing I'm going to do is I'm going to take this 2,401 and I'm going to move it to the other side. So I end up with 3,528, and it's still equal to 98R. So the last thing I'm going to do is just divide by 98, and when I divide that by 98, it's going to give me 36 for my radius. Now, for this next problem, you have to determine, where is the error in this problem? What is wrong with it exactly? So they have their radius drawn, they have a tangent drawn, and they're claiming that because 11 squared plus 60 squared equals 61 squared, then it is a right triangle, so that xy is going to be tangent. All right, well, the issue here is where they're saying the right angle is, since this is the hypotenuse, they're claiming that this is a right angle. And I don't care whether or not that's a right angle. What I want to look for is to see, is the right angle down here with the radius and the tangent. That's what I'm looking for. So this side should be my hypotenuse instead. That's the problem. The last theorem in this section once again deals with tangents. Okay, but instead of just one, now we have multiple tangents. So as you can see in my picture over here, we have RS, which is tangent to circle P, and TS, which is tangent to circle P. Now, they connect, or they intersect outside my circle, and because they're both tangent to my circle, that means they are going to be congruent. So for this next example, right away they tell me that JK is tangent and JM is tangent. So both of them only touch my circle at one point, at K and at M. They intersect at point J. So right away I know since they're both tangent, then they must be congruent. So to solve for x, I'm going to take my two expressions and I'm going to set them equal to each other. Well, once again, I want to solve for x, so I want to get x all by itself. So I'm going to move this 10 over. I'm going to end up with 3x squared equals 27. And then to get x by itself, now I'm going to have to divide. Divide by 3, which is going to leave me with x squared equals 9. And the last thing I have to do then is just take the square root. So it looks like for my final answer, it's technically going to be positive and negative 3 because I'm taking the square root down here. And both of these will work if I plug them in for x.